can you solve this math challenge? Here's the question. Solve for the real value of x. Given this equation, 4 raised to negative 1 over x plus 6 raised to negative 1 over x equals 9 raised to negative 1 over x. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So our goal here is to solve for the real value of x, given this crazy equation. Now, negative 1 over x on the exponent is very annoying. So first thing to do is to replace this exponent negative 1 over x. So let's take this as n. So let n equals negative 1 over x. Therefore, we can replace all exponent as n. So we have 4 raised to n plus 6 raised to n equals 9 raised to n. The equation now looks simple than before. So now, let's set aside this substitution, but take note that n is equivalent to negative 1 over x. We will use this later on. Now, let's focus on this equation. Now, first thing to take note here is this 6, because this 6 is just 2 times 3. Now, why we do that? Because this 4 is just 2 squared, and this 9 is 3 squared. Now, using this law of exponent, if we have b raised to a raised to the power of c, it is equivalent to b raised to c raised to the power of a. Therefore, 2 squared raised to the power of n can be written as 2 raised to n raised to 2, and 3 raised to 2 raised to the power of n can be written as 3 raised to n raised to the power of 2. Now, let's focus on the middle expression, 2 times 3 raised to the power of n. Using this identity, if you have a times b raised to the power of c, it is equivalent to a raised to c times b raised to the power of c. So, 2 times 3 raised to n can be written as follows, 2 raised to n times 3 raised to n. Now, the good thing here is if we divide all terms by 3 raised to n quantity squared, the right-hand side becomes 1. And we have 2 raised to n quantity squared over 3 raised to n raised to 2 plus 2 raised to n times 3 raised to n all over 3 raised to n quantity squared. Now, we can now cancel out 3 raised to n on the numerator and 1 3 raised to n on the denominator. This will give us 2 raised to n over 3 raised to the power of n. Now, let's use some laws of exponent again. Alright, so if we have a raised to c over b raised to c, it is equivalent to a over b raised to the power of c. So, 2 raised to n over 3 raised to n can be written as 2 over 3 raised to the power of n. Now, on this expression, we can do the same thing. So, this can be written as 2 raised to n over 3 raised to n raised to the power of 2. Also, 2 raised to n over 3 raised to n, using this identity again, we can rewrite this as 2 over 3 raised to the power of n, and again, raised to the power of 2. Now, another substitution is needed because take note that we have a common term of 2 over 3 raised to the power of n. Now, let's have m. So, let m be equal to 2 over 3 raised to the power of n. So, this equation now becomes m squared plus m equals 1. Again, let's set aside this substitution and let's focus on this equation. So we have m squared plus m equals 1. So to solve for the value of m, let's subtract 1 on both sides or equate this to 0. Now to solve for the value of n, we will use the quadratic formula, namely negative b plus or minus square root of b squared minus 4ac all over 2a, wherein a is the coefficient of m squared, b is the coefficient of m, and c is the constant term. Now, if we use the quadratic formula, using this quadratic formula, we get the value of m as follows. We have negative 1 plus or minus square root of 5 all over 2. Now, take note. M is equivalent to 2 over 3 raised to the power of n. This is an exponential equation. So, m cannot be a negative number, or m must be greater than 0. Therefore, the case wherein m equals negative 1 minus square root of 5 over 2 is not possible. So, we can disregard this case. So we can say that m must be equal to negative 1 plus square root of 5 all over 2. Now, our goal here is to solve for the value of x. So let's focus now first on these two equations involving m. Now this m is equivalent to 2 over 3 raised to n, and this m is equivalent to negative 1 plus square root of 5 all over 2. Since they are both equal to m, so we can equate those two expressions. So now, 2 over 3 raised to n equals negative 1 plus square root of 5 all over 2. Now, how to solve for the value of n? At this point, we need to rewrite this exponential equation into a logarithmic equation. So if we have b raised to a equals c, this can be written as a equals logarithm of c to the base of b. So this equation right here in the middle can be written as follows. We have n equals logarithm of negative 1 plus square root of 5 all over 2 to the base of 2 over 3. Now, we want the value of x, of course. So this two equation is equivalent to n, and the other n is equivalent to negative 1 over x. So we can equate those expressions. So now we have negative 1 over x equals logarithm of negative 1 plus square root of 5 all over 2 to the base of 2 over 3. Now to solve for the value of x, first thing we need to do is to multiply both sides by negative 1. And then, to get the value of x, let's get the reciprocal on both sides. So x equals negative 1 all over logarithm of negative 1 plus square root of 5 all over 2 to the base of 2 over 3. Now, take note of this identity. If we have 1 over logarithm of c to the base of b, it is equivalent to logarithm of b to the base of c. So the right-hand side of our equation can be written as logarithm of 2 over 3 to the base of negative 1 plus square root of 5 over 2. Now, this negative power, using this identity, if we have a times logarithm of b to the base of c, it is equivalent to logarithm of b raised to the power of a to the base of c. Now, this factor of negative 1 can be the exponent of 2 over 3, like this, using this identity. Now, 2 over 3 raised to negative 1 can be simplified as 3 over 2. Therefore, our answer to this question, what is the value of x in this equation? And our answer is logarithm of 3 over 2 to the base of negative 1 plus square root of 5 over 2. And as always, we are done.